Hi, this is Stefan Magneron. You're watching episode 9 of the 3-Day Cottage.
On the last episode, we got into the weather barrier, the air barrier, and the vapor barrier, and we also completed the air sealing around the entire envelope. On this episode, we're going to get into the blower door test, and then we're going to talk about that as well as those standards with Stefan Magneron of Homesol Building Solutions. Having someone like Stefan involved in the project from the very beginning is extremely important for a successful high-performance build. I always tell people we need to approach this as an integrated design process, or IDP. So that means that you have everybody involved from the very beginning. That's the designer or architect, that's the contractor, and that's the energy advisor, because each one of those individuals, each one of those teams brings a lot of important information to the project. There's nothing worse than getting too far down the road and then having to redesign. You're actually losing time and actually losing money as well.
So we take a house as a system approach, meaning that when we consult on a project, whether it's a new house or an existing house, we look at the thermal enclosure first and see how far we can take the thermal enclosure with respect to the insulation levels and the windows and the air tightness target that we set. Once we have that, then we can look at the mechanicals. So the ventilation system, the hot water system, the heating and cooling systems. And then once we have that, that completes the energy model. And theoretically, we'll have the loads or the total annual energy consumption estimation down low enough that all that's required to get to net zero are solar panels.
In order to hit the Net Zero Ready certification, we need to hit an ACH, air changes per hour, of 1.5 or less. Now, what makes this a net zero home versus a net zero ready home is really just the addition of the solar panels, which Kim can do at a later date whenever they're ready.
So a blower door test is a test for air tightness. That's essentially how leaky the house is or how airtight it is. We do a depressurization test in which the fan sucks air out of the house, and in doing so sucks air into the house through all the air leaks. Air tightness is important for homes for multiple reasons. The main reason is comfort, because the fewer drafts you have, the more comfortable the house is. The second part, which perhaps is a bit more important on the longevity of the home, is the durability aspect. So if you can imagine air leaking through the house, that is a highway for air and moisture and potential condensation risks. The side benefit of air tightness is energy efficiency and the reduction of wasted heat through all those air leaks. Another benefit of air tightness is lowering of loads. And by loads, I mean the size of the heating and cooling equipment to keep filtration of exterior air, especially during the extremes of the cold and the heat.
Stefan didn't make the 4-hour trip from Ottawa in order to do the blower door test. However, he was generous enough to lend us his equipment. And luckily, the man behind the camera, Brian, had experience with the blower door equipment because he worked for Homesol at one point. On our first run of the blower door test, we got a reading of 1.22, which is great because we had to hit 1.5 or less. However, we know we can always do better. And that is why we do these blower door tests, to make sure we are hitting the target and also find those areas where we do have leakage. During the walkthrough, we found the air leakage coming through any penetrations through the air barrier, which was really around the pipes coming up through the slab, so our poly around that, and also the ERV pipes leaving the building. This is why it's so important to do this walkthrough, to do this test before everything gets closed up, because you get a second chance to seal up these areas that will inevitably need some sort of additional attention to detail. After we sealed up those leaky areas, we did another blower door test and we got it down to 1.05 ACH, which is actually an improvement of about 15% just from adding some additional tapes around those areas where we could feel the air coming through. That actually gave us an equivalent air leakage area of about 26.2 square feet as well. And the readings we were getting was telling us that we had a lot of little holes as opposed to one big hole. So that could be even leaking through all the staples that we have in the Intello Plus as an example. So overall, this is great because it's really difficult to seal up a small building as opposed to a large building. And that just goes to show you by taping up those few little areas that we had, we improved the air tightness by 15%. So something like that on a larger home would have a much smaller impact, which makes it a lot easier to seal up. One thing we needed to be careful with in this cottage was the fact that we were putting a wood burning appliance into it. Usually this is something you see in older houses all the time. They have an open fireplace and they would use that to help heat the house. But in reality, that fireplace can actually suck a lot of the heat out of the rest of the house. So it might heat the area that it's in, but what it does is it needs oxygen. It needs that oxygen to fuel the fire. And as that oxygen is being fed to the fire, it's really sucking it through the leaky holes in your house into the fire and out the chimney. So in this case, we don't have a lot of holes in the house. So where is that oxygen going to come from? So one thing you need to consider when you're doing this, and what we did here, is you actually need to have a direct line to the fresh air outside. So this is a sealed unit that is bringing fresh air in directly from the outside into the fireplace itself and then out the chimney. So you get that radiated heat from the stove itself, but it's not sucking air out of the house, it's just using air from outside. Our plan is to go back and do a final blower door test once Kim and her partner have all of the interior done, and it'll be really interesting to see where we end up. For example, if a lot of that air leakage was coming through those tiny little holes left by the staples in the Intello, all of those areas got covered with the 2x2s that we put on to create the chase for the electrical, so we weren't penetrating the air barrier.
So air tightness testing is not just for new construction. We also use it for existing homes when we're evaluating them for programs like the Greener Homes Grant program that's on at the moment, or any other program. It also provides us with a baseline of what the house is, so we can put that into the energy model. It also gives us the opportunity to look for air leaks while the house is being depressurized, because then we can walk around the house with either the infrared camera or feeling with our hands in certain locations. And we can advise the homeowner on how they could go about sealing those major air leaks. Then in the energy model, we can show them the impact that air tightness and reducing that air leakage, that ACH, what impact that has on the energy waste that would be going out through those leaks. And that's highlighted in the report that we provide for an existing home evaluation.
Depending on where you live, there may be other programs available to you as well. For example, Ottawa just released a program called the Better Homes Ottawa Loan Program, where people can borrow money interest-free to improve their home. On our next video, we're going to get into the ventilation system as well as what we did for heating and cooling and what we're using to heat the water in this net zero cottage. If you enjoyed this episode, be sure to check out this video on another net zero home that we're building, where we used a product called Aero Barrier that helped us improve the ACH, the air changes per hour, by 68% in less than 6 hours. Until next time, remember to live consciously.